All right, to finish up the notes for chapter 4, we're going to talk about what they call oxidation reduction reactions. And what happens in an oxidation reduction reaction, it usually happens in a single replacement or a synthesis or even a decomposition. But what happens is one of the substances, one of the reactants, loses electrons and one of them gains electrons. So they call it oxidation reduction because they're going to change their oxidation number. Oxidation number is their charge. Okay, when they're combined with something, their charge is +1, +2, +3 if they're a metal. If they're a non-metal, an anion, it's going to be, -3, -2, -1. Okay, so what happens, here's the reaction where we've got calcium and oxygen. Now calcium's all by itself, so it doesn't have an oxidation number. Okay, if you have an element that's in its, pure form, it's not combined, its oxidation number is always 0. The same thing with oxygen over here. Oxygen O2, it's pure oxygen, there's nothing combined. So both of them, their oxidation is 0. Now when you combine them, what happens is calcium becomes +2 and oxygen becomes -2. All right? Now because they're combined, now they have oxidation numbers. Okay? So what you look for is if they either lose electrons or they gain electrons. All right? And you guys, oxidation doesn't mean it's oxygen. Don't get confused by that. Well, how do I tell? I wonder. No, we don't have it. Okay, so what I would do then is I look. Calcium goes from 0 to +2. Okay, so if it goes from 0 to +2, the only way it can become +2 is to lose electrons. So it lost electrons, so it's oxidized. Okay, oxygen goes from 0 to -2. Well, the only way it can go to -2 is to gain 2 electrons, to gain 2 negative charges. So oxygen is reduced. See what I was saying about don't think oxygen's the one that's oxidized? And I think it says it up here. Calcium is oxidized because it loses electrons. Oxygen is reduced because it gains electrons. There's a little saying, it's called oil rig. Oxidation is loss. Reduction is gain. And again, you got to remember, we're talking about electrons. So if oxidation is lost, it actually becomes more positive. So oxidation, it becomes more positive. Reduction, it becomes more negative. Excuse me. Okay. And one cannot occur without the other. So if this doesn't have, if one gets oxidized, one has to get reduced. You can't just have one oxidized and not one reduced. They have to, because you have to have that change in charges. Okay. These are called redox. Reduction, oxidation reactions. Except up here, it's oxidation reaction. You guys, it really doesn't matter. But the thing to remember is one's going to gain electrons, one's going to lose electrons. The one that gains electrons becomes more negative, it's reduced. The one that loses electrons becomes more positive and is oxidized. Okay? So remember the oxidation number. You have oxidation number for elements. It's on that chart, that periodic table I gave you with the charges. Those are their standard ones. Sometimes you have to figure it out, especially with the nonmetals. Okay, the metals tend to be the same, but the nonmetals can switch. Like nitrogen can be -3, but it also can be +5. So sometimes you got to figure them out when you have a polyatomic ion. Okay, and it says it's a bookkeeping method. It doesn't really imply that atoms have these charges, but it's to show you how to get to these charges. Okay, so oxidation numbers are, when you have a compound, they have to be 0. So you can use those numbers, the ones you know, to figure out ones you don't know. Okay? So rules to assign. Atoms in their elemental form have an oxidation number 0. That's what I was showing you. Calcium, if it's Ca and it's not combined, 0. Oxygen, not combined, 0. Any element that's not combined with something else, and don't worry about the diatomics, you guys, because I said oxygen, said O2. It's still pure oxygen. Its oxidation number is 0. So anytime you have an element that's not combined with something, it's 0. Okay? If their monatomic ion is the same, and again, that's the chart I was talking about. If you look like the first row of lithium and sodium and potassium, they're all +1. That's their oxidation number. Okay? The halogens like fluorine, chlorine, bromine, iodine, those guys are all -1. That's their oxidation number. Okay? Okay, so what happens if you have these other guys that you're not sure of? Okay, nonmetals are the ones that can be kind of a pain in the butt, I got to tell you. Sometimes they can be negative, sometimes they can be positive. It just depends. Oxygen in most cases is -2, and I would say 95% of the time. But if it's with peroxide, if it's H2O2, then it's -1. Doesn't happen very often. Okay, hydrogen is usually +1, but it can also be -1. You know, hydrogen is a rebel. Hydrogen does whatever it wants whenever it wants. But if you take hydrogen and bond it to a nonmetal, it's usually, you know, it's -1 when it's bonded to a metal. It's +1 when it's bonded to a nonmetal. And again, you can figure that. I'll show you how to figure that out. And then again, fluorine and the other halogens are usually -1. But sometimes when they're combined with oxygen, they can change. So it's the nonmetals that sometimes vary. The metals are pretty steadfast, okay? They pretty much keep, you know, if they're not, if like calcium, like I said, by itself is 0, but when it combines with something, it's +2, and that doesn't change, all right? So at least there's some constants in there. Okay, so when you're trying to figure out the oxidation number, okay, the sum of the oxidation numbers in a compound has to equal 0, because a compound does not have an overall charge. So what you do basically is you look at the ones you know to find the ones you don't know. We did this before. I'm trying to remember. Oh yeah, when we were writing formulas for compounds. Okay, like if it was copper 1 or copper 2, how do we know? We look at what it's combined with. Well, it's kind of the same thing. We look at we take the charges of the ones we know for sure, and then we use those to find the ones we don't know. Okay, you got to count every atom, no matter how large the subscript. Okay, so if it says H7, that's 7 positive charges because hydrogen's +1. Okay, so you gotta, you know, you gotta remember the subscripts in there. Oxygen, if it's like SO4 in parentheses with a 3 on the outside, well, that's 12 oxygen. So oxygen, 3 times 4, we got 12 oxygen. Oxygen's charge is 2, so we got 24 negative charges, so we got to balance those out. So you got to keep that in mind when you're doing these, okay? All right, and I'll show you those later, I promise. I'll do like my hand. Do you guys think I should be a hand model on my recordings? Anyway, the last part of the notes talks about displacement reactions, and again, a displacement is we already did double. Remember, we looked for a precipitate. We looked for one that was insoluble. Well, what we're going to do now is we're going to look at displacement, a single displacement reaction, and we can determine whether it will happen or not by using what they call an activity series. Okay, in a displacement reaction, and I don't know if you can read this down here, we've got HCl, which is hydrochloric acid, and magnesium. Okay, now we're going to look, I know that's kind of small, but okay, hydrogen here is +1 and chlorine's -1. There's their numbers. And magnesium, since it's by itself, is just 0. Now we go over here and we see hydrogen goes from +1 to 0 because by itself it's 0. Magnesium over here is +2 and chlorine is -1. So chlorine stays the same, so we know it didn't get oxidized or reduced. Hydrogen went from +1 to 0. Okay, so it became less negative, so loss. You know, remember oil rig? Oil rig is oxidation is loss. Well, it didn't lose electrons, it gained 1 electron. It gained 1 negative charge. It became less positive. So hydrogen is reduced. And then magnesium goes from 0 to +2. It became more positive, so magnesium is oxidized. We can also check, I'll have an activity series chart that I need you guys to run off. It'll be in these notes to see if this reaction really happens. That's the other thing we're going to look at. The chart looks like this, and it'll be in the notes. But what it does is it tells, I can figure out if this reaction is going to happen. In this reaction, magnesium replaces hydrogen. And I look at my chart and I find magnesium, and hydrogen has to be below it. Okay, so in an activity series chart, the most reactive are on top, and then they go through their activity and they list them in order. And if you look on there and you find magnesium, it's way above hydrogen. So this reaction is going to happen. That's the other thing we're going to look at. Do these reactions really happen? So if you're looking at replacement, and again, I'll show you this later when I do my hand model. But this chart, you look for, these guys are the most reactive, these guys are the least. So it'll replace anything below it. So this reaction will happen as well. Okay. An ion is displaced and replaced. Again, magnesium replaces hydrogen. So I look on my chart, magnesium will replace hydrogen. Okay. Here's the chart. Okay. So here's magnesium and here's hydrogen. So yep, this is going to happen. Now, if it was the other way around, if hydrogen was supposed to replace magnesium, that reaction is not going to happen. Okay, so if you look down here, if you're looking for a reaction where gold isn't going to replace anything, gold doesn't really replace anything. That's why we like gold for our jewelry. It's not very reactive, unless you get cheap rings and then they turn your finger green. Okay, anyway, so lithium, if you have a reaction where lithium replaces, always going to happen. So that's how you look at, like if I had a reaction where I expected zinc to replace calcium. Well, here's zinc, here's calcium. Not going to happen. If I have calcium replacing zinc, going to happen. That's how it works, okay? So these are all metals except for they throw hydrogen in there because, you know, again, hydrogen's a rebel. But this is how you figure out if a reaction is going to occur, okay? The elements above hydrogen will replace it. But hydrogen can only replace these guys below it. All right? And a reactive metal is oxidized to form a cation. Again, we talked about cations. Cations are positively charged, and they're going to be your metals. Okay? Here's another one. We have silver replacing copper. Okay, let's go back here. Here is silver, and here's copper. So is silver going to replace copper? It's not going to, you know, we have this. We have silver replacing copper. I mean, copper replacing silver. I'm sorry. Copper is replacing silver. Okay, so if you go back here, here's copper, here's silver. Barely. They're pretty close to each other, but that reaction is going to happen. Now, if it was the other way around, if silver were replacing copper, that wouldn't happen. Okay? Okay, so we got silver and copper, and we know the reaction happens because silver is more reactive. And let's see if we can figure out who's oxidized and who's reduced. Okay, silver goes from +1 to 0. So it becomes more negative, so it's reduced. Copper goes from 0 to +2. It becomes more positive. It becomes oxidized. Okay? And that's that. All right. So again, I'll do a video and I'll show you how to figure out more of these if the reaction occurs, and I'll show you how to figure out which element is oxidized and which element's reduced. And that's the end of chapter 4.